All right, starting Unit 4 here with growth and decay. There's this equation that we're going to be starting with to kind of get ourselves a head start. It looks kind of like this. And this A and this B value that are here both actually have a significant impact on how my graph is going to look. So my first focus is going to be on figuring out if something is growth, if it gets bigger as time goes along, hopefully like my bank account or something like that, versus decay, maybe how the medication goes into your body and over time it kind of reduces in the amount of effect that it has. So here's how I figure out right off the bat if something's going to be growth or decay. Okay. This B value, this number that I'm taking to the x power, determines whether it's going to be growth or decay. If it's greater than 1, it's going to be growth. My graph is going to go up to the right. So like for instance in this example in number 1, my B value is 3. It's the one I'm taking to the exponent. And we'll talk a little later about that, what that 1/2 does. But anytime that we see that B value greater than 1, we can know it's growth even if I didn't see the graph part. Okay. And then if I have a B value that's between 0 and 1, might be a decimal, might be a fraction, sort of like we have here, where my B value is 1/2, that, with one exception, which we'll talk about in a little bit, is going to be decay. It's going to go down to the right as we're doing these. Now, one other thing I'm going to make mention of while we're here, you might notice with the graphs that as they're going along, it seems like they get down to the x-axis and they kind of curve off. That's not a coincidence. Because there's this little imaginary dotted line here that kind of is like the you can't cross this. It's called an asymptote. Okay? And this imaginary line is going to be right here, and it will move up and down if we have shifts later. But in other words, we do not want to go past that line. Never, 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 ever. It kind of tells us where we can stop. And I'll show you on the calculator here in a minute how you can actually find that if you're not sure on where it is. But that's basically it on figuring out if something's going to be growth or decay. So, okay, what if they don't give me a graph? Don't be frightened. It's not a big deal. As I get down to the graphing part, now before I actually punch this in the calculator and look, let's see if we can kind of apply something we learned a minute ago. Okay, in number 3, my B value is 2. So does that mean this should be growth or decay? Growth, because my B value is bigger than 1. So this graph, when I get done, should kind of look like number 1 did. Now, do I have to have a graphing calculator to graph these? No. I hear some of you, yes, no. Okay. I could, if I needed to. Some of these I may even know off the top of my head. Like, for instance, before I even plug it in, I'm like, okay, 2 to the 0 power, well, anything to the 0 power is 1. Okay, I know that. And 2 to the first power is 2. Okay. 2 to the second power is 4. I got this. 2 to the third power is 8. So, I mean, I've got a little bit of an idea of what things are going to look like if I didn't have the calculator. And to be perfectly honest, I could even, if I didn't have a graphing calculator, type in something like 2 to the negative first power, because again, every calculator has an exponent button. Now, I'm not going to use the decimals here, because I want you to see something. So I'm going to do my math enter. I want to put this in as a fraction. And I'm going to do that with one more of these, and then we're going to take a peek at something for a second, because there's going to be a pattern that develops. I bet if you look at this for a minute, you can figure out what that -3 value is going to be. Okay? Because if I start to look, I'm like, hey, 2 1/2, it's just like flipping 2 over. Oh, 4 1/4. Oh, I'm just like putting in the denominator. Oh, so 8 1/8. Okay. Now, is that going to happen exactly that way in everyone? No, but you can kind of see how I could wing it on this if I needed to. Now, if I want to double check, and I will in this case, okay, I take a peek at my graph. I notice again, it's not going below the x-axis. My dots look like that's doing the same thing. I'm feeling pretty good. I'll look at my chart just to be sure. Check me out. 8, 4, 2, 1, 0.5, which is a half, 0.25, which is a quarter. Okay, I did it on my own. Pat self on back. But here's the other thing I'll show you while we're doing this. This whole thing on why it never goes below 0. If I keep scrolling up, notice how the numbers get tinier and tinier and tinier, but they never go past 0. Even when you get here, you're like, well, wait, it went to 9.8. But that e to the negative 4 just means it's 0.000098. Okay? It just means we're getting really close to 0. It doesn't mean we're going into negatives or anything like that. So when I actually look at the graph, it's still going to go that way. So once I have the graph, I can get me some info. And we're going to see in a minute that I really don't even need the graph to get this info. My growth or decay factor, okay, was that B value that I was looking for. That's just another fancy word for it. Okay, my Y-intercept. Now remember, your Y-intercept occurs when x equals 0. So I can use my chart on a lot of these if I pulled it up on the calculator. But I'll tell you, your Y-intercept is going to always be at 0, 1 unless your number in front changes, your A value, which we'll see in a little while. Okay? But otherwise, for a base graph like this, it's 0, 1 every time. My domain, again, x values left to right, well, goes forever to the left. That's going to extend and go forever to the right. So that's my easy one with this. For these, it will always, let me even write that. Always will be negative infinity to infinity, whether it's growth or decay for your domain. Now my range, it depends a little bit. My range, if I go from bottom to top, what value am I getting really close to on the bottom? 0, because I never see it go into the negatives with my y, but it goes up forever. Okay. Your range will always be 0 to infinity unless there is an up or down shift, which we'll start dealing with tomorrow. Otherwise, what value are we getting really, really close to but never passing? That's basically how we determine our range. That's where that asymptote that I was talking about comes into play. So when we're doing any of these, and I'll basically ask for these things every time we're doing one of these just to start making connections so we can make this go a little better. All right, so we're like 4. Now let's see if we can knock out some stuff on 4 before we graph it. We'll see. Okay, what's my growth or decay factor? What's my B value?
Wait, what about that?
I almost got too far ahead of myself. Thank you. What about the end behavior? Got a chat here. Okay, end behavior. It's our flashback to the past. Okay. End behavior, there's always going to be 2 parts. That's why I'm writing this f of x, which stands for y, but we're talking in function notation. And we always want to see what's happening to the graph as x heads to the left or to the right. So again, negative infinity occurs as x is going to the left. So basically what I'm asking is, as x goes to the left, what value is y approaching? And here's a hint. Your choices are always going to be the 2 range values. So 0. Okay? So what this first sentence now says is, y approaches 0 as x goes left. Going left, we're getting closer and closer to 0 for y. Okay. Well, that kind of doesn't leave us many options for the second one. So as x goes to the right, what's y approaching? Up, up, up forever. It's approaching infinity. So you're like, oh, so basically I got at least a 50-50 shot every time, because if it's always going to be my range values that go here. Oh, okay. And I can kind of see that. Okay. Thank you again for mentioning that, because it'll be easier to make the connection now when we do it with number 4. But those are the type things, again, as I practice, this will get easier and easier. And this is going to happen again when we get to logarithms. So if I get it down now, it's going to make that a much easier thing to be able to do. Okay, now we're ready to get going into number 4 here. All right, so what's my growth or decay factor for 4? 1/2. So if it's 1/2, is it growth or decay? It's decay, because it's between 0 and 1. So I know my graph's going to be going down to the right. So again, I've got choices on how I want to tackle this. I mean, if I'm in class and I've got the calculator, fine, I'll go ahead and use it. I'm not going to say I never should. So let's get this in. Make sure, I'm going to stress this again. Whenever you're dealing with a fraction, when you're graphing, you've got to make sure that you get the parentheses in. Because if you don't, you're not going to be graphing 1/2 to the x power. You're going to be graphing 1/2 to the x. That's totally different. Down to the right. Okay, that makes sense. So I pull my chart. Let me get my chart down to where. And you start to look at this for a minute. You're like, hey, those numbers look kind of familiar. Actually, they look real familiar, because basically, if I scooch this just a little, it's the same numbers I just dealt with, except they got flipped. You're like, oh, but that makes sense, because if I flip 2, it's 1/2. Oh, so it's the same graph, just kind of its mirror image over the y-axis. So I'm going to go ahead. I'm going to get those guys plotted. Again, I don't want to go past the x-axis, so be very careful with your graph. You can hug the x-axis, but it's not going through. So once I get that graphed, the rest of my info is going to be pretty easy to come up with. My y-intercept, we said before, unless there's a change in my a value, unless there was a number here out front, is always going to be 0, 1. So, okay, that was pretty easy.
So then if the domain and range are always the same, that behavior is always going to be the same too, right?
Interesting question. The question was, if you could not hear it, if the domain and range on these are going to be the same so far, is the end behavior going to be the same? Well, let's take a peek. So when I get to my end behavior, now I will admit, because I'm looking, I'm like, well, the range numbers are the same. They're 0 and infinity. So what could possibly be different when I get to my end behavior? Well, let's think about this for a second. When I start to look at this, okay, as x goes to the left, am I approaching 0 or infinity for y? Infinity. So then as I go to the right, I'm approaching 0. They flipped. So yeah, when you're doing growth versus decay, it just basically, yeah, your ranges are going to flip depending on which one it is. Okay? But again, we'll kind of start to see some connections with all of this. And we have already with what we've been doing. Like I said, we're just kind of doing some introing to some things today. We're going to expand as we go day by day because we don't want to go over the top here. Because our goal this first day is just to get through this first page of notes here, front and back, and then we'll deal with some other stuff moving forward. Okay. We're going to take a peek on the graphing calculator at what happens when our a value starts to change. So what I'm going to do is I'm going to pop this up. Probably not a bad idea for you to do the same. Just so you can get used to playing with this a bit. You're like, all right, 2 to the x. Let's look at our chart here. So here's what we're going to take a peek at. We're going to go ahead, we're going to graph this. We're going to label these as we go along so we can tell the difference between them. Because it doesn't help much to do all this graphing if we can't tell them apart from each other. Okay, so here's my first one. I'm going to label it with an A. But here's the other thing I want us to take note of when we're doing this. Okay. What's my y-intercept on this one?
1.
Okay, my y-intercept is at 1 or 0, 1. Keep that in mind as we start doing some of the others, okay? Because I'm going to graph them on the same graph. So, if you've got different colors, that's even better. So I'm going to leave that first one. I'm going to type in the second one. So I got 5 times 2 to the x power. Now if I look at the picture, okay, there's my original graph. There's my new one. Okay, it's kind of going up steeper. But let's look at our chart so we can kind of tell the difference here. Okay, my second one, this is the new one that I just plotted. Now you're like, okay, Harty, I can't plot some of these. Like 340, I can't plot 340. Shoot, 110 is even a press. Well, that's okay. Well, so 110, I can get that one in. And 0, 5. And -1, 2.5. -2, 1.25. -3, I'm a little above a half, but I'm still not going to go below the axis, but it gets really steep. But again, here's the part I want you to take note of. What's your y-intercept this time?
110.
Okay. My y-intercept, remember, is where my x value is 0. So when I look over, I see it's at 5. Interesting. Might become more interesting here in a second. We'll see. So you're like, okay. Now I'm not going to put 3 of them on the same graph. That'd be a little crazy. So I'm going to replace my second one. Okay, with my -1. So I look at the graph. There's my original. Ooh, there's my second one. That's kind of interesting. So I look at my chart. Again, I'm on this far side. And I start to plot these. And I'm looking, I'm like, hey, it's like a mirror image of the one that's above. Again, still hugging the axis, I'm just below the x-axis this time. But I notice when I look at my y-intercept, I'm like, it's at 0, -1. I think I may be seeing a pattern developing here. 0, 1, 0, 5. Same as the a value. 0, -1. My a value is -1. I wonder if this theory might work. So if my theory is correct, what should the y-intercept be on letter E? Okay, it should be at 0, -3. But let's find out. So I go back to y equals. I get my -3 times 2x typed in. I take a look at my picture. I'm like, ooh, it's kind of getting steeper as it goes down. Okay, but I want to look at the chart. Oh, there it is. When x equals 0, y equals -3. I was right. So that's a relationship that these particular graphs have. When I'm working on them, I want to make sure that I pay attention to things like that. Because if I can find a pattern, that makes it a lot easier for me to work, and I have to actually do less work when I'm trying to finish those off. So here kind of in summary is what's going on in this particular part. We saw what B does to my graph. Okay, B determines if it's growth or decay. A if A is larger, my slope, air quotes, because it's not technically slope, this isn't linear, gets steeper. I noticed on letter B and letter E, it went up really fast or down really fast because that value got so much bigger. But we also noticed, okay, that A moves the Y-intercept. Whatever that value was in front, that's where my Y-intercept moved. And then if it was positive, my graph opened upward. Letters A and B both went up. But when A was negative, like it was in C and E, it opened down. Lots of connections to be able to make on this when we actually take a peek to see what's happening, instead of just punching it on the calculator, putting down random numbers and going, on how this works. So, let's try to put this to use. We'll start throwing in a couple little twists more here now as we get into these last couple of graph examples. So, okay. Graph the functions. Before we ever graph it, though, we should be able to get some info here. So, first question. Is this one going to be growth or decay? What's my B value? My B value is 3. It's always the value that we're taking to that x power. So if my B value is 3, is it growth or decay? Growth. Where's my Y-intercept going to be?
I don't know how to figure that out.
Look up at the pattern we just did in the section up above. There's a direct connection between your A value and the Y-intercept. Notice again, when it was the A value was 5, we moved to 5. When it was -1, we were at -1. Let's slide back down. What's my A value? We need to take advantage of patterns. Yes, my A value is 1/2. Okay, it's the number that's not being taken to the x power. So since my A value is 1/2, my Y-intercept, since there are no shifts yet going on, is at 0, 1/2. Okay, there's a lot of info I can get on this before I ever have to move anything. I'm like, okay, so I also know my domain and my range before I even start looking at the picture. Look at all the info I've got. I don't even have a picture to work with yet. And when we discussed it on the front page, we probably even could do the end behavior knowing that it's growth, but if we're not comfortable with that yet, that's okay. So you're like, okay, I need all these values, Harty. I need all these values. I don't want to do them in my brain. You could even do them with a calculator. We've seen that, but if we go to the chart on this, okay, let me clear this other stuff out. Okay, reminders again. If you're going to do a fraction, you could use 0.5 here if you wanted to. Make sure you get that closed. I'll hit graph because I know it should be growth. Okay, it's growth, so I didn't do anything silly. And again, if you get some fractions here, you get some decimals, you know, it's about what you're comfortable with to be able to graph. Yes, I know some of them are not going to fit on the graph, especially if they have big values out in front. Just do the best you can with what you got. But again, we're not going below the x-axis under any circumstances right now. Because again, my range is 0 to infinity. Well, if it's...
Are those fractions or decimals?
These are decimals. I'm going along with this. I just happened to have gotten my y-intercept first, so I just wrote it in as a fraction because I wanted to make the connection with those. But as far as the rest of these go, normally I'll just go to a couple of decimal points if it's something like that.
So if it's like crazy, don't just get rid of the decimals.
Yeah, that's fine. That's fine. And you will get into some crazy decimals on some of these. It will happen to you on that, especially as you get closer and closer to that x-axis. -1 was 0.17. But again, get those values in on your calculator. And then when you do the end behavior, my x's will always be the same. Why? Because my domain's always the same. It's always -infinity to infinity. So I can always write those two same things down on the right. I'll always have one plus and one minus to represent left and right. And then again, as x goes left, heads towards -infinity, which one of my range values am I approaching? As we go left, we're getting closer to 0. As I go right, I'm getting closer and closer to positive infinity. Just follow along with your finger. Just kind of see which one's which, and then it's kind of elimination to figure it out from there. So, okay, you know how I normally work. It always seems like there's a twist to everything, right? This is no different. So number 6 is the twist problem. So let's take a peek at this. Before I go to the graphing calculator, should this be growth or decay? What's my b value? So if you've got to go active into this function, if you just sit and you're like with it, you're not going to get it. My b value is always the one going to the x exponent. 4. So now what should it be? Growth. But let's look at the picture. So I get this one, I type it in, and I'm like, okay, 3 times 4 to the -x graph. Wait a minute. When the b value is above 1, it's supposed to be growth. That looks like decay. Did I type it in wrong? No. Right, here's what's going on here. What's happening here is that blasted -x that's up here, okay, I need to be careful of this because here's what's happening. When I have 4 to the -x, when we have negative exponents, we normally flip things, right? So this is going to act like if I took 4 and flipped it, so notice if I flip the number inside, it makes the -x positive. That's what it's going to act like. If I were to type 3 times 1/4 to the x in my calculator, I'd get the same graph. So that's what I have to watch for. So here, I'm going to have to kind of make a mental note to myself, okay, my factor here actually would be 1/4 because the -x is going to make it flip. And when it's 1/4, now it's between 0 and 1, so it's decay. Man. Now, is that going to change my y-intercept? Well, let's see. Nope, still 0, 3. Still just 0 in my a value. Okay, so the negative doesn't change that. That's nice. At least one thing's not changing. And then again, I'm not going to jump up and down and scream if you don't jot down every single value in the table for this. I mean, because I know you're more than likely going to be using the calculator to do that. And there's nothing wrong with that. But again, I want you to be accurate with your points. Don't just slap down something and be like, oh, whatever. I'm going to be looking, is your y-intercept accurate? Are you not going below the x-axis? And some things like that. So, okay. We've survived the twist. Now we just got to make sure we're paying attention when we do the rest of our work here. My domain does not change. My range does not change. You're like, well, wait a minute. But now it's going like up to down instead of down to up. That really doesn't change it, but remember what your range is. Your range is from the bottom value of y, which still is approaching 0, to the top. Just because the order is different doesn't mean my range is going to change, but it can mess with my end behavior. So once I get here, again, my x's will always be the same too. It doesn't matter which way I put the positive and the negative as long as I get the right f of x to go with it. So I get to here and I go, okay. As x goes left, am I approaching 0 or infinity? Infinity, because I'm going up, which means the other one has to be 0. Okay, process of elimination. Once I get the first one, got the second one down. So, well, I've heard worse things, so I'll take So the last thing that goes with this, and it's a small intro to what we're getting into tomorrow, and then we're done. Yeah, no, that isn't anything that was mentioned. So, when a real-life quantity, we're actually going to get into applications of this in our next lesson, increases by a fixed amount each year, there's this equation, okay? A, which is what I start with. It may be money, it may be bacteria, it may be, I don't know. Okay, where A is my initial amount, R is my rate in a decimal form, and we're going to talk about that in just a second. And T is typically going to be your time in years, but that can change. It may be minutes, it may be days, it can be some other things like that. But when I put together this 1 plus R for my rate, that's called my growth factor. Okay. Then, if it decreases or starts to shrink or decay, I just change the sign in the middle to a minus. And the minus would be my decay factor. So, let's say you're asked to produce a growth factor when there's a 35% rate of change, a positive one. Okay. How do I write 35% as a decimal? Point something something. Okay, I'm with you. Are there any zeros in the something something, or is it just like 0.35? No zeros here. If I have zeros, I'd be into single digits.
I was just,
You're just testing it out. I know. Okay. Okay, so 0.35. I move my decimal point 2 places to the left on whatever it is. So when I get the growth factor, because it's plus, it's 1 plus that value. Okay, and normally we go ahead and add those up. 1 plus 0.35 would be 1.35. Okay, that's how much it's going to grow by each year. That's it. Okay, we're trying to keep life simple here. Now, if I have a negative one, it's going to be decaying. Now, ooh, this one's different. Negative 125%. Yee. How do I write negative 125% as a decimal? Well, let's think. 125, 2 places to the left. Now you're like, well, now what if I forget this? Is there like a way on a calculator or something I could do it? Yes. Because basically, if you're trying to turn any number into a percentage, all you got to do is take the number and divide it by 100, and you'll get the decimal form. So like if you had 7%, you could do 7 divided by 100. You'd get the decimal form, and so on. So here, I'd do 1 minus 1.25. So yes, I can get negative factors and do it that way.
Wouldn't you plus it as minus?
I could write it if I wanted to as 1 plus negative 1.25. I know what you're thinking. Are you thinking I'm going to do minus and then it'd be minus a negative? So it'd actually end up looking like plus. It wouldn't in this case. So if I want to go that route, I could, but I've just got to make sure that I get that set, because normally they'll tell me a rate is a positive. Yeah. Good question. So your task in going along with this And again, keep the note packet handy because we will be finishing it. Okay, it's going to be to work on this, and I meant to put my date on the other one to make sure. Ooh, I wrote that small. It is some book stuff, but I've got a sheet where you're not having to rewrite things, and all you're doing, okay, for the first 3 questions, once you have them in front of you, is it growth or decay? Okay, what's my B value? And then writing down my Y-intercept. For 34 and 36, it's just like what we just did. Okay? Figure out the rate of change, figure out the growth or decay factor. As far as that goes, to figure that out. And finally, on the back is the actual problems for you to graph. Find the Y-intercept. Look at some of those different things and kind of answer some of the questions that way. Like I said, tomorrow we're going to get into some applications plus some graphs that start to shift, and then we'll kind of wrap it up on that third day with a little more practice just to make sure that we're in the right